So hello everyone, this is the day 44th of my journey to improve my communication skills. And today we have college holiday, so the whole day I was in the hostel only, and I spent most of the time for studying for the third IA as well as the lab internal because both are coming simultaneously. So I have to prepare well for both the lab IA and third IA also. So what I studied in compiler design, the two modules are coming. First one is uh, parsers and the second one is code generator. So in parser, basically what we have to study, we need to study. I need to study about that bottom up parsers, types of the bottom up parsers. There are two types: LR parser. Second one is operator precedence. So in our syllabus, there is only one parser is mentioned, which is LR1, and which is further classified into four parts. First one is LR0 parser, second one is SLR1, third one is CLR1, and fourth one is LALR1. So all the four parsers are quite similar to each other. There's just slight change in the process to solve these parsers expressions or grammar. So when we talk about the LR0 parser, in LR0 parsers, we first of all we need to find the augmented matrix. Once we will find the augment grammar, we will convert that augment grammar into the LR0 items. And after converting that into the LR0 items, we need to apply the goto operation on each and every item present in the LR0 items. So once we read each and every string of the LR0 items, and we will get finally the dot in the end of the string, then we will convert all the strings into the action goto table, which is the known as the LR0 parser table. So once we will draw the table and put the value of the iterations in the table, that's all about the LR0 parser. Similarly, SLR1, CLR1, and LLR1, there is a slight change while filling the iterations or shift reduce operation in the table. That's all about the compiler design third module. And the fifth module is all about the code generation, which is the last phase of the compiler design. And in this module, I studied about the basic blocks and flowchart. So basic block is basically a sequence of the consecutive iterations, which have one entry point and the one exit point. And more importantly, it is used to solve the complex problems or complex instructions the simple way with the in the compiler design, and we can easily generate the target output or target code with the help of basic blocks and the flowchart. Flowchart is basically a directed graph which is used to represent the relationship between the basic blocks. So after that, I studied about the what are the possible causes, what are the possible side effects that comes when we generate the code from the compiler. So the first one is uh, the first one is input to the code generator. So if we give a wrong input to the code generators, then definitely we will get the wrong output. This is the first issue that can be happen when we generate the code with the help of code generator. Second issue that we are going to encounter is target machine. So it is very difficult to build a compiler which can be working on any kind of the machine. Like if we talk about the Windows, if we talk about the Linux, Mac, so it's very difficult to build a compiler so that which can understand each and every instruction for the different software or different operating system. So that is the second problem which we are encountering with when we solve the simple expressions with the in the compiler design. And the third problem is storage management. So while solving the simple instruction, the compiler should keep in the mind that which which instruction should allocate the memory, and when there is a need to deallocate the memory. So all things will take care when we are solving the problem in compiler design. And the fourth one is register allocation. So whenever the compiler is solve the instructions, the compiler should know whether the variable should go to the register or it should go to in the memory. And registers have faster than memory, so the priority or the precedence should be registered first and then it will go to the memory. So that should also keep in the mind to solve the instruction in the under the compiler to generate the optimum code. And another one is instruction selection. So basically instruction selection is, suppose there are two instructions, both are doing the same, both are giving the same output. So the compiler should recognize which instruction is smaller, which instruction is faster, and which can execute optimally than the others. So it should, and both are giving the same output. So the compiler should select the one of the best of the those two instruction. So that is known as the instruction selection. And then after that, another issue which is encountered with the code generation is code optimization. So the code optimization is also another important part of the compiler code generation phase. So in this, what happened? So suppose there are two instructions, both are of similar kind of the variables. So the compiler should optimize the code, write the two instruction in the single instruction, that is known as the code optimization. And then error handling and debugging, which is basically used to handle the errors. If any error is encountered during the code generations, compiler itself should handle the errors. That is the main goal of the error handling. Then handling control flow. Control flow is basically for the loops, while loop, for loop, and iteration, if else statements. So whenever we are applying the for loop, while loop, the compiler should know that where should go, where we have where there is a need to end the statement, that should be known by the compiler. So yeah, that are all about the basic problems which are encountered when we solve simple instructions through the compiler and to generate the optimum code. So after that, I studied about the basic block, why there is a need of the basic block optimization, and then simple code generator. These both these questions are correlated with the first two questions. So that's all which I studied in the compiler design. And after compiler design, I studied about a little bit DSA for the placement. Today I studied about the um, quicksort. So quicksort is basically a sorting algorithm in which we sort the array. We can sort it either in ascending order or descending order as per the requirement. So how it works? Suppose given an array of n elements, we first need to decide a pivot element, and on the basis of pivot element, we divide the array into the two parts. On the left side, all the elements should be less than the pivot element, and on the right side, all the elements should be greater than the pivot element. And this we will done continuously until or unless uh, we will get the sorted array. So that's all about the quicksort, and the time complexity for the quicksort is big of n log n, and space complexity is big of 1, which is a constant, or and it is also considered as the best sorting algorithm on the basis of the time complexity and the space complexity. So that's all for the day 44th of my journey to improve my communication skills. And thank you for watching. Stay healthy, stay happy, and focus towards your goal, and be consistent, because consistency is the only key to success. Thank you for watching.